Okay, this is rotations, and this is day 3. And a rotation is a turn. And again, just like the other days we've done, you already know what a rotation is. It's when we've got a turn that happens to something. And we're going to start by talking about a couple of things here. One is that a rotation preserves the distance between 2 points, like this distance stays the same, just like we've seen before. It's not changing the size of this. It doesn't change the angles that are in here. This angle is the same as this angle. And it just moves the angle that it rotates the whole picture there. And so I'm going to give you a couple of vocab words that might be new. The point that I'm rotating around, if I take this and I hold the paper like this and I turn it like this, the point where I'm turning it is called the center of rotation. And the angle that I turn it through, how far I turn it, is called the angle of rotation. I know, very clever names. And you'll notice that when I turn it, this distance here stays the same as this distance here. How far it is from the center of rotation stays the same. And this angle is our angle of rotation that we had right there. One note that we make right here is we're going to rotate it through an angle. It tells us the angle we go. And when I rotate it, it's going to tell me what I'm rotating it around. And for here, we're going to say that it's counterclockwise unless we say otherwise. So first of all, let's just write down this direction is counterclockwise and this direction is clockwise. I want you to write this on your paper so you remember it. And just like we did notation with the other kinds, we're going to have notation with this. And let's see if we can figure out what the notation is. On some of the other ones, we memorized it when we did the slides, but on these, it's just easiest to look at the pictures, and let's see if we can figure it out from the given picture. If I'm starting at G, here's my pre-image, and I'm going to go to this image. I had 2 and 3, and then over here I have -3 and 2. So first of all, what happened to the 2 and the 3? Well, I switched the positions of them, where what was the Y here moved to the front, and the X moved to the back here like this. And then what's the other thing that happened? Well, this one became a negative of what it was there. So that's how we write it down. So when I'm doing a rotation, I swap the order plus I put a negative when I'm going 90 degrees counterclockwise. I also want to point out to you that going 90 degrees counterclockwise is the same thing as if I went this direction that far. Well, how far is that? Well, if this is 90 degrees this direction, and I know all the way around is 360, then that's the same thing as going 270 in the other direction. So this is the same thing as 270 degrees clockwise. Okay. How about 180? If I go 180 counterclockwise, that's the same thing as going 180 degrees counterclockwise. They're the same thing no matter which direction I go. Now let's see what the rule is here. Well, 2, 3, 2, 3, so the order stayed the same on the X and Y. What did change? Well, these both became negative when we went down here. So that's all that changes. The order stays the same, they just both become negative. On the next one, now we're going to go 270 counterclockwise, which happens to be the same thing as 90 degrees clockwise. It's the same thing if I went that way. And again, just like up here, we saw this point, the coordinates switched. So this is going to be Y, comma, X now. And what else changed? Well, this went from 3 to 3 to 3, -2. So the second one is the one that became negative. And finally here, 360 all the way around. What do you think that does? It takes me right back to the same position. So this just goes right back to the same position. Now again, this was going counterclockwise. Would going clockwise make it any different? No, it would be the same thing. So this is the same thing no matter which direction I go. I think out of all the kinds we do, rotations are sometimes the trickiest ones to actually plot the new points of. Remember, we're talking about everything is counterclockwise unless it says otherwise. So we're going to go 90 degrees. So this is going to turn to this position here. And I always suggest you start by, we're going to rotate around the origin, and I suggest you start by turning your paper and seeing what it's going to look like. If I turn 90 degrees, this is going to end up in this position. So my final answer is going to look like this. When I get it done, it's going to look like this here, in this quadrant. It's going to be coming up to this point, and it's going to be right there. So, we can also look back at our rules that we had earlier. Let's see if I can get it where we have it. If I'm going 90 degrees counterclockwise, remember this rule we had here. Each one of my x's, each one of my points is going to change to this. So my x and my y's swap, and my first term on my new one becomes negative. So I'm going to go from 2, -1 to, I've got to swap the things, 1, -2. This first point will end up right here. This point was at -2, -1. Now it's at 1, -2. Notice it follows our rules. It swapped the 2 and the 1. And the first one changed signs. This one changed signs when I put it over there. Okay, pause the video and do each of the other ones. So here's each of my new points. This one went from -1, 8 to 8, -1. It swapped the order, and notice that this one changed from negative to positive. And this one went from -7, -2 to 2, -7. And again, notice that that one changed positions. And when I get it drawn, does it look like it rotated? Does it look like that got rotated? It does. Okay, you work on the next ones, looking back at your rules from the previous side to help you. Pause the video, and then come back to the video to check. Okay, so now we're going to go 180 around the origin. And remember here, we said that all it is I keep the xy, I just make both of them negative. So I just change the sign on both of them. So this was -7, 8, now it's 7, -8. Notice this negatives here doesn't actually mean to make them both negative. It actually means to change the sign on both of them. So the one that was negative becomes positive, and the one that's positive becomes negative. I did that for each one of my points. Then I went back and plotted them here. Does it in fact look like this rotated 180 degrees? It does. I did the same thing on the next one. I went back to our rules that we had here. I switched the x and y, and I make the second one change the sign on the second one. I did that on each one of these here. Then I took and I plotted my points, and this is a 270 degrees counterclockwise rotation. Okay, on this next part, I wrote down our rules from the previous page, just like we've been doing. Remember, these are counterclockwise, and then I just applied it to each one of these. So here, I switch them, and I change the sign, oops, that should be negative. I change the sign of this one here from positive to negative. And this one, I just change the sign of both of these. And this one, I switch the order, and I change the sign of the second one. So it went from negative to positive. Repeat that with each of the other ones as well. And finally, just like we had lines of symmetry in the first one, we have symmetry in rotation as well. But here we're talking about degrees. Remember, when we talk about degrees, if I go this far, this is 180, and if I go all the way around, this is 360. So in order to find how far I'm rotating, I just take 360 and divide it by how many ever times it's going to match up. So for instance, in a square, as I start rotating this, the first time this image matches the next one, if I'm rotating it down and rotating it down like this, is when this corner ends up right here. If I rotate it again, it'll be when it meets here and here. So I take my 360 divided by 4 places where it'll match up, and that gives me 90 degrees is my rotational symmetry. On the next one, we have an equilateral triangle, which means all the sides are equal. So again, here, when I rotate it, I'm rotating it counterclockwise, it's going to match up when it gets here and when it gets here. which is 3 places. There's 360 divided by 3 tells me this is 120 degrees of rotation. So what are these here? Well, this one, is it going to match up? If I start rotating this, when will it match up? It's not going to match up until it comes all the way back here, so this is 360 degrees. It basically is only going to match up if I go all the way around. On this one, the star, how often is it going to match up? Well, at each one of these points it'll match up. So I do 360 divided by 5 is 72 degrees. On this one, it's a regular polygon. Again, we talked about that before. A regular polygon is when it has all the sides are equal and all the angles are equal. So this one is going to match up every time I go around. So it has 6 times it's going to match up. So 360 divided by 6 means it's 60 degrees.